I have an idea. Why don't we try knocking doors?
Yeah, let's do that.
That would be cool. That would be cool.
There's no one.
Oh my god, it's open. Oh.
Let's go inside. There's no.
It's in here.
Oh.
Oh, it's so cool here.
I don't think we should be here because this place is a bit creepy, right? It's giving me chills. We should leave now, guys.
So dark here.
Oh, so dark.
Is there any light here?
Right?
It's locked.
It's locked.
Oh my gosh, oh my gosh, oh my gosh.
Wait. Did you hear that?
Yeah.
My. This is what you get for being naughty kids.
Hey, old man, this isn't cool. Let us out.
Tell us the way out.
What can we do?
You entered a place that isn't yours. Now you must solve this equation. The first thing you should do is verification. You must verify that n is equals to the number of Sn, or vice versa.
Yeah. It looks so familiar.
It's like a donut. Oh, math induction. I remember that.
Yeah. Do you still remember how to solve it?
Yes. Can I have paper and pen?
Oh, sure, babe. Here.
Done. This is the solution I've come up. In order to prove that the given is divisible by 9, for any integer where n is greater or equal to 1, we should verify the given first. We should substitute n to 1, 2, and 3. Minus 4 is obvious that it is divisible by 9. Second is 13 raised to 2 minus 4 raised to 2 is 169 minus 16. The answer will be 153. It is divisible by 9 because if you will divide it, the answer is 17. So the third step is 13 raised to 3 minus 4 raised to 3. It is 2,197 minus 64. So if you will minus it, 2,133 is divisible by 9 because if you will divide it, the answer will be 237.
So, yeah, I think the old man is already speaking again. Let's go. Yes.
Job well done. Like in a puzzle, it's still incomplete. And here's a clue for you.
What's that? Wait, let me handle this because it's word puzzle and I love word puzzles. It's hypothesis. And
Yeah, you're right.
Yeah, and I think I still remember how to solve it.
Okay, come on.
Give me the paper and pens.
Okay, you want to do that?
Okay, so the second step is induction hypothesis. It is where we are going to substitute n into k. So we have here 9 is divisible by 13 raised to n minus 4 raised to n. If we are going to substitute k into n, we have 9 is divisible by 13 raised to k minus 4 raised to k. If we are going to simplify it, we have here 13 raised to k minus 4 raised to k is equals to 9 cubed.
Verification and hypothesis is not enough. You need to give me a proof in order to believe you. It is to see to believe after all.
I got enough of this, man. Let me solve this problem. Just wait.
Wow, how did you do that?
It's easy peasy. So, our next step is the proof of induction, where n is substituted by the k plus 1. So, our given is 9 is divisible by 13 raised to n minus 4 raised to n. If we are going to substitute n into k plus 1, the equation will be 9 is divisible by 13 raised to k plus 1 minus 4 raised to k plus 1. So, in order to get the 9 cube, we should extract the value, which is the 13 raised to k plus 1 minus 4 raised to k plus 1. So how do we extract this? We all know the law of exponent, where if we're going to multiply two exponent, the two exponent will be summed up. So for example, a is raised to x and multiplied by a raised to y, we get the product, which is the a raised to x and y. So the same goes by in here, where we extracted 13 raised to k plus 1 minus 4 raised to k plus 1. Where we do it vice versa, we get 13 raised to k times 13 raised to 1 minus 4 raised to k times 4 raised to 1. So in this state, we should find the 9 in order to say that this given equation is divisible by 9. So in order to do that, we should put out the first term, which is the 13 raised to k, where we do that in here. So where did we get this? So in order to say that this equation is divisible by 9, we should find the value of 9 in that equation. So if we are going to subtract 4 in 13, we will get 9. So in that case, we'll already get the value of 9. So proceeding to the next step, 13 raised to k times 9 plus 4 that we get in the 13 raised to 1. Next is we minus the 4 times 4 raised to k. Where would we get this value? It is in this form, but we factor out, or we put out the 4 inside the parentheses in order to get 4 raised to k, where we can see in the 13 raised to k minus 4 raised to k. So next, 9 is divisible by 9 times 13 raised to k plus 4 times 13 raised to k minus 4 times 4 raised to k. Where do we get this 9 times 13 raised to k plus 4 times 13 raised to k? In order to get this, we should distribute the 13k in 9 and 4. So we put out this outside, where we get this, and put this outside, and where we get this. So our last step, in order to get the 9 cube, we should know that 9 is divisible by 9 times 13 raised to k plus 4 times 13 raised to k minus 4 raised to k. So where did we get this? In order to get this, we should combine these two terms, where we get 13 raised to k and 4 raised to k. In this situation, we get the 9 cube.
Hey, I think you still need to solve this one.
Wow! Why do I get so many computation in these problems? We need to first to multiply the 9q in the left values. So in here, 9 is divisible by 9 times 13 raised to k plus 4 times 9 cubed. In order to get this 36, we should multiply the 4 times 9, where we get 36 cubed. Last step, we should combine 9 times 13 raised to k plus 36 cubed, where we get 9 is divisible by 9 times 13 raised to k plus 4k. How did it go that our 36 became 4? In order to get this 4, we should divide 36 to 9, where we get 9 times 13 raised to k plus 4 cubed. So that is the final answer.
We need to put the conclusion.
I think I can handle it.
Yay!
We're done! Woo!